Hello again. Welcome back to our Retired Grandpa's Electrical 101 channel. Today we're going to build a 5-volt regulated power supply. Power supply will be using the center tap secondary full wave rectifier type. So first, we draw the diagram. So we have a transformer. We have the primary voltage, say 110 volts, and secondary voltage of 9 volts. So now we connect a full wave system. So we have two diodes, okay, and then we do have a capacitor type filter. And then after the filter, we'll put our regulator. This will be a 7800 or 78XX. Okay. So we will use a 7800 7805 means a 5-volt regulator, positive. And after the regulator, we have another final filter capacitor. Okay. And we're going to connect a load to load the system to around 5 volt with 5 volt approximately 500 milliamps. So by calculation, we should be putting somewhere around a 25 or 12.5 ohm resistor. So that will be our diagram. So the diode, we will use a 1N4001, which is rated at 1 amp 50 volt. Okay, for a 500 milliamp load, we will be needing a 1000 microfarad filter capacitor and final 220 microfarad final filter capacitor. Okay, so that will be our full diagram. So we have a ground here, ground or negative. So this is your positive, this is your negative. Okay. So let me show you the components. We have two diodes here, 1N4001. We have a filter capacitor, 1000 microfarad, and another filter capacitor. This is 220 microfarad, and we have the regulator, 7805 regulator. So notice we handle this carefully to avoid static damage to the device. We handle it with a anti-static pad. So we don't want to touch the terminals while they are not connected. After connected, they can be touched with no problem. But before that, we want to avoid static damage to the device. Okay. So also in the IC semiconductor, we have 3 pin, right? 3 pins. So 3 pin means we have 1, 2, 3. So 1 is your input, 2 is your ground, and 3 is your output. So here you see by top view, this is 1, this is input, the middle pin is 2 or ground, and 2 is also connected to the body, the flange. We call it the flange. So these 2 are connected, and 3 is your output, 5-volt output. So the flange, the purpose of this flange is to connect a heatsink to the device so that it will not overheat during operation. So what it means is, okay, here is an example of how it is connected. So we screw the flange to a metal plate. Okay, great. So the metal plate will dissipate the heat generated by the device towards the outside air. Okay, so it will not overheat. So without the aluminum plate, without that plate, or what we call without the heat sink, this device will overheat and it will have a thermal runaway. It will damage itself. So the plate, metal plate, will help it to maintain a safe temperature. So it can be aluminum or copper plate, okay, thick enough to dissipate the heat. So this is probably around 1 millimeter thick. Okay, it can be thicker or wider, but of course you don't want to make the heat sink wide enough or wider than the casing you're putting the whole project into. So you'll have to regulate the size of the heat sink. And of course, bigger is better. Okay. So now we will first mount these components into the breadboard, what we call breadboard, before we finalize it into a PCB. So breadboard is something like this. You may have seen this before. Some are larger or some are smaller. So let me divide this into, okay. So we'll be using only a few portions because there are only a few components. Okay. So, but first, before we begin, how are they connected? How are these holes connected? So, look at the group of holes. These are all interconnected. And so, these also. These are all interconnected. So, they are all interconnected that way. So when you look at underneath, see they have metal connectors underneath. So you see this whole different rows with different rows, right? Okay. So they are individually separated from between rows, but these are connected together. Okay. These blue trays here, these are all connected together until that where it's cut off, similar to the red, similar to here. So it's here, see, it's connected all the way until that line. Okay, so the way to connect it, let me show you some example. Let's say you have a resistor. Let's say you have a resistor and capacitor. Say you want to connect those two. So in the breadboard, there are so many ways. One way is to first, okay, so you have a resistor, individual connected from first point to second point. First point to second point. Now, series it with capacitor. So, the capacitor will be connected maybe like this. So, you have connected the capacitor and resistor together here. These are independent. Okay. Or you can do it this way. I'll put it further away. Okay. You can connect it this way also. Can you see it? So this is connected to that. Because remember, these holes are all connected. Okay. Okay. So that's how it is used. or so many other combinations. Okay. Now let's wire our without the transformer. I will put the transformer later on. Let's wire our diode capacitor in the regulator. So first we get the diode. I am going to use it this way. By the way, the diode, you have a polarity. Okay. This means you see a band here. You see a white band. That is where the arrow is pointing. Okay. Okay. So I'll put the second one. I can choose any place here. So these two are these two. And these two, they are shorted. So I'll put a short here. I'll put a jumper wire. Like so. Okay. So now these two are shorted together. Okay. This point. Then I'll put the capacitor any point here, positive. But let me extend this so we'll have more space here. Use this space rather than crowding it here. So I'm going to extend this here. This is where I will put the positive side of the capacitor. So this is the positive side. The negative side is with the can. The rubber side is the positive side. There's also an arrow showing negative here. So I'll put it anywhere here. Free to put it anywhere, as long as the other end is free. But this side is this side. Okay. Now, after that, we have a regulator. Now, for our device, I made a socket adapter. You see, it's a 3-wire adapter. So I can plug this. I can plug this into that later on. So these 3 are extended to here, 3 pin. So it's better to work this way because this one will be mounted not on the PCB. It will mounted independent of the PCB. So you will need a extension anyway. So I take this out first. Okay. So this one. So this is pin 1. Pin 1, pin 2, pin 3. Okay. So pin 1 is input. input 1. So you will connect it here. I will connect it here. Oh, hang on. So I plug it here. That's pin 1. Plug here. So pin 2 will be your ground. Okay. So pin 2 will go to somewhere similar to this. So I'll put a wire, jump a wire from here to here. So I jump a wire from here, okay? So these are all connected. So jump a wire from here to down there. There. So I jump a wire from here, from the pin 2 to ground. Okay, so that's the point. And the third point will be the output, and it will connect to a capacitor. So that output. So I'll jump a wire here to here also. Okay. There you go. Somewhere down here, free. Okay. So this will be my output. Output also is connected to, okay, let me move this a little bit so that we'll have a place to put the capacitor. Okay, there you go. And the last capacitor is 220. So this is the negative side, the one with the band, and this blank one is positive. So positive goes to here. Oh, not that. Here. So the positive goes to here. The negative will go to this bundle here. So let me put a jumper from here to here. There. So the negative goes to negative or ground. So this point is ground, the common ground. So I'll put the negative wire here later. Okay, put it there. Now this positive, this is the output. So this is where we will put the load. So here I made a load of parallel connected resistor to make up 12.5 ohms. Okay. So let me put the load here. Bend it down. So I put this load in the positive and negative. So positive and negative across. So that is this one. Okay, so it's done now. We have, you check it. So we have two diodes, one capacitor, second capacitor, and the there. So there you are. We have the completed 5-volt regulator. Now it is time for testing. Okay, let's get the transformer. Let me show you first what I did with the transformer. So this whole thing, so the power switch and transformer. So this is your transformer, 500 milliamp with 0, 9 volt, 9 volt. Okay, the primary is here, right into there. So this is my line voltage, 110 volt. Put it here, pass through a switch and a fuse. There must be always a fuse in your project or in your experiment, so that anything you short here, it should blow the fuse. Okay, so it will not burn. Okay, and make sure you encase it in a container so that there's no danger of touching. So even if you touch here, there's no danger. Okay. So let's connect the breadboard. Here we go. So first the negative or the zero line, that is hold on, this line is this one, and these two are the two red wires. Okay, so the zero line, remember this is our ground. Okay, this is also our ground. So I'll plug it there, on, like so, and then the 9 volt, one of them gets to the diode. Okay, that's it. And then the other 9 volt goes to the other diode. There you go, and that's finished. So let me move it a little bit so that we'll have some place to put our tester for measurement. Okay. So first, let me go and plug it into wall socket. All right, I'm back. So DC volt. Power on. Let's measure from here to here. We got 5.01 volts. Perfect. Okay, that is the regulated output after the regulator. But what is the voltage prior to that, unregulated, which measured it on this diode? It's 9.64 volts. That is loaded. Now, what happens when we take out the load for a while? Take this out, take one leg out, and measure again with unloaded. There it is 11.98, 11.9, around 12 volts. That is unloaded. How about the output unloaded? 5.08. That is 5.08 volts unloaded. Okay, so we load it down with 12.5 ohms. We get 5.02. Okay, that's very good regulator. 5.02 to 5.08, from no load to 500 milliamps load. Okay, that's how the regulator works. Now when you feel the heatsink, it starts to warm up a little bit, and of course the load is heating up. Okay, it's heating up. It's hot to the touch, but the heatsink, it's just, it's a little bit warm. It's not yet. Okay, it's warming up a little bit. So that's the use of the heatsink. Okay, let's measure it again. 5.02. The input to the regulator is, oh, I got the wrong probe. It's 9.63. So unload it again. $11.97, nearly 12 volts. Okay, so from unloaded to load, the input voltage is from 12 volt down to, let's check that again. Right. It's not connected. Let's connect the load once more. Okay, I missed the right slot. Okay. So it's down to 9.65, and the output still 5 volt. 5.05 to be exact. Okay, so we have made our 5-volt regulator. It's working fine. So now it's time to put this into small PC board and mount this heatsink. Now remember, this heatsink is also connected to the ground of the regulator, so you can mount this near a ground point, no problem. Okay, it can be standing like this. It can be probably the best way standing, because you get the smallest area. If you make it lie down, it's too big area. Okay. All right. I hope you like the project, and comment down there if you have any questions. I'll be glad to answer them, and I hope this is helpful. Okay, now power off all, and until next topic,